Hi, thank you. Welcome, everyone. In this presentation, I will talk about our simulation project that we've been developing for Western Digital and DSV. Uh, I would like to quickly introduce the companies first. So I'm representing here Epic InnoLabs. We are a small industrial digitalization consulting company located in Budapest. Our focus is on simulation modeling, production scheduling, and data analytics. And our customers on this project are Western Digital, which is one of the largest hard drive manufacturers on the market, and DSV, which is a global transport and logistics company. We have been worked together before on other projects, so this is not our first time together. And here's the outline of this presentation. I will talk about the project first, our challenges, and why we chose simulation, and I will go into details on the models on the second half of this presentation. So the subject of this project is a logistics center in Thailand, which is supplied by two factories, and it is fulfilling orders to many customers. And one of the main properties of this warehouse is that there are two types of storage spaces inside the warehouse. There's an automatic storage and retrieval system, and there are also some conventional manually serviced pallet racks. This project was born before the customers would like to have a tool, a model of this logistics center, which could be used to fed forecast into it and then return to with the expected values for some identified key performance indicators like resource and storage utilization values, process lead times, and so on. To give an insight into the scope of the facility, this warehouse has 2,000 square meters of floor space only for pick, pack, and staging processes. It can hold more than 12,000 pallets at the same time, and also the volume of the operations is quite high. There are about 1,500 pallets moved daily to perform the inbound and outbound operations, and they are done at 10 loading docks. So what were the challenges in this logistics center? But the operations are quite complex because the load on the warehouse originating from the received pallets and the orders can vary greatly during the day because there is a milk run process on the inbound pallets, but the quantity is very different, and also the customers tend to pick up their orders late in the afternoon, so then there's a big change. There's a big jump in the load on the warehouse. And on the other hand, from the factories, there are mostly partial pallets arriving to the warehouse, which means that they need to be merged eventually inside the warehouse, which is an additional task. And there are lots of product matrices. This means that there are lots of pallet configurations which need to be taken care of, and this all leads to very complex processes which are difficult to oversee. And on the other hand, they also have some issues with the storage space being overutilized. And because of the varying load, it's very hard to decide beforehand how many operators they will need during the day. So they are often under and overutilized. How could simulation help with these problems? Well, even to build a model, we need to have a deep understanding of the processes to be able to create a valid representation of the system. So after we have a model, we already have a better grip on the situation, and with the model we can run many types of experiments, like system optimization, what if scenarios, and in this model we will also have a data-driven solution at the end, which will be able to predict the system behavior in response to the forecast data fed into it. Analogic was chosen for this task because it's a very flexible software since it's Java-based, and it also supports multi-method modeling. And we also use some of the built-in features that were developed for warehouse modeling. And for this project, it was also important that it's easy to visualize the processes inside the warehouse. And for later in the project, we also plan to move to AnyLogic Cloud and integrate the model business analytics tools at the customer side. So it's important to mention here that this is still an ongoing project. We have achieved some milestones so far, but there is still some steps ahead. Right now, we have already finished our base model. It is already validated, and we have run the first round of experiments. And we have also refined some parts of this model, like we have implemented this ABC logic in the ASRS, and we have also developed some more detailed KPI resource monitoring, which can be used to measure these more detailed KPIs in the model. And the next steps will be to expand the time horizon. Right now, we are simulating 3 months, and we plan on to expand this to 7 months. And after that, we will be able to run our second round of experiments, which will focus on resource utilization and warehouse productivity. Let's move on to the model. Right now, we are working with historical data, which is fed into the model in the shape of Excel files. The model inputs are the initial state of the inventory, the inbound data, which is the records of the received products, outbound data, which are the order records, and the outbound trucks, which take away these orders. And we also needed the product matrix, which describes the different type of products, their palette configurations, and other relevant properties. Other parameters like forklift speed and scanning time, they are not fed from external sources. They are defined directly in the model. I think the modeling challenges are best explained by going through the process flow. But of course, as always, I think the biggest challenge here was to find the appropriate level of detail to model. Yeah, so for the inbound, we are talking about from the time the pallets arrive to the warehouse until they are put away to their place. Here we needed to create this custom storage logic, mainly because the ASRS has this ABC logic, which means that the different products need to be put away to a specific section at the ASRS based on their categories. But these categories are also weekly recalculated, and above that, the ASRS has also double deep racks, so we had to manually coordinate the picking and placing operations. For the pick pack processes, we had to obey to quite strict rules on picking the pallets. And of course, it could happen that not all of the products are needed from a pallet to satisfy the order. So the relevant cartons needed to be taken from the pallet and continue with the pick pack flow, and the other products needed to be put back to the storage. So material flow was flowing in both directions at the same time. For the outbound process, when the trucks take away their orders, in theory, all of the orders should be prepared and staged already at this time. But of course, it could happen that some pallets are still in the pick pack process. So we had to handle these late products so that the truck knows if it still needs to wait for some other pallets, even if they are not put together yet. They are still before merging. And as I mentioned before, there's an overutilization issue in this warehouse, and they try to combat this by in less busier times, they will pick some pallets from the SRS and they will merge them to free up some space. So we also had to implement this to copy the actual state of the warehouse. And for the most important thing for this was that it couldn't hold up the actual pick pack process where actual orders were being put together. We have been solving these problems by combining discrete event simulation and agent-based modeling. The base of the model was created by using the process modeling library. Some agents were created, some agent types were defined for the pallets, for for the workers of the warehouse, for material handling equipment like forklifts and power pallets, and for other constructs that did not need to be agent types. We have been defining simple Java classes for them, so cartons and orders, but like this, and where we had to coordinate the warehouse operations. And for example, on this picture we have the crane agents. So as I mentioned, we had to coordinate the picking and placing operations. We have applied state charts for this. So based on the active state, it will decide which task is currently active. And we have used stage charts for resource monitoring for each resource. We have defined some more detailed states other than idle and busy, and we are measuring the time spent in each state. These state charts are controlled by messaging the agents. Now let's see some clips from a simulation run. For the client, it was important that they can also use this simulation. So we had to create a nicer user interface for it, which is intuitive to use. So even before simulation run, we can change some parameters. Right now, I am changing the head counts of some worker groups, and after that, the data is loaded and the warehouse is initialized. And here we have a busier time in the warehouse, some pick-pack process and outbound processes. It is possible to highlight some workers working on this on some specific tasks. These palette colorings are reflecting their load level, so it is easy to see if a palette is full or if there are very few products on them. And yeah, so we also have a 3D presentation. And besides this load level coloring, there is also a possibility to color them by their ABC categories to check whether they are at the right place in the warehouse. But the ASRs also push them to their place at night. So here are some KPI indicators. These are related to the statistics of the products. We have some KPIs on lead times, and here are some resource utilization and productivity charts that we can check during runtime. But of course, it is not enough to look at the charts during model runtime. We also need the data afterwards to be able to correctly process and analyze them. So right now, the data is exported to Excel sheets. Our main KPIs identified are related to storage space and pallet utilization. So how well loaded are the pallets and how much free space is in the warehouse at any given moment. We are counting the non-value-added product touches. These are the touches that are happening, for example, during housekeeping and when the products need to be put back into the warehouse because a pallet needed to be broken up, so which are not a part of the standard process flow. We are also monitoring process cycle times for unloading, loading, put away, and the pick pack process. From these combined, we can also calculate the throughput time of the pallets in the warehouse. So as I've mentioned, we are monitoring the resource utilization values, and we are also doing this in 2-hour periods to see if there are some periods in the day when they are always more utilized than other times. And we're also looking at the labor hours, meaning that we are keeping count of how many pallets were processed in a 2-hour period, how many orders. We have information about the products and segments and so on. And we are running two types of experiments right now. These are both parameter variation experiments. One of them is when we study the effects of changing the headcounts on the lead times and productivity and other KPIs in the warehouse. And we also vary the parameters of the ABC logic, meaning that how far we move into the time. So the ABC logic is calculated based on the number of orders for every given product, and we are looking at 1 week, 2 week, and how fast we need to drop the categories, something like that. So we will study the effects of it on the lead times. Yes, so as I've mentioned, I cannot tell you numbers right now. I cannot tell you about X amounts of dollars saved. We are still in the middle of this project, but I think we are at the right track to create something really powerful for our clients at Western Digital and DSV. Thank you very much. I hope this project is interesting to you. If you have any questions, you can ask them now or contact me later. Okay, so question. How did we program the production planning logic? Intelligence algorithm, which orders should be placed, or do you just simulate? Right now, we only simulate with historic data. So we're expecting the forecast data in this form as that I've presented. So we will have the forecasted orders data. So we will not need to program the orders ourselves. How long did it take to build the model as it is today? We've been working for this model for close to 1 year, but there were only two of us in the beginning, and right now I'm the only modeler on this project. So we are a bit low on resources. Do you think your model can be applied in similar logistics problems? Not this model, I think, because at the start of this project, we weren't thinking about generalizing it. So it is good for this warehouse only, but we have been talking about making a more general model. By how much did the revenue increase? Maybe this was a question from a bit more earlier. So as I said, I can't tell you revenue increase. Can't tell you about the revenue increase because we are not at that point yet in the model, in the project. With complexities in your model, could you share how you verify and validate your model? Right now, the verifying and validation was done by comparing the simulation data with the actual data. So some of our KPIs can be measured in the real warehouse too, and we were comparing the real data and the simulated data, and this is how we validated so far. As the model apparently has a lot of agents, is the execution time fast or slow? It depends. As I said, we've been simulating 3 months. I need to optimize the code. If I disable the evening put away when the pallets are being put to the right category, then the model runs under 10 minutes. If I enable this, then I think it goes to 20 minutes. So some optimization is needed. What is the coolest logic insight you could share based on this development? Good question. I don't know, everything can be done. Maybe it won't be the best. I don't know. I don't have a good answer to this. I'm sorry. But I will think about it. Do you plan to extend this model? What do you mean by extend this to other parts of the supply chain, or I'm not sure. Great model. Do you build conceptual model before building this huge model? Well, we tried to create one, but some of the details have been taken to the daylight during model development, so we had to adjust our conceptual models. Was your model exported to the cloud? No, but it is planned. So so we plan on moving to the cloud with this model because we would like to integrate this with Tableau and other business analytics tools. Okay, so I think that was all for today. I will think on Felipe's question. I will try to get up an answer with this. Thank you for having me. I hope you enjoyed my presentation. Goodbye.
Yeah, we did. Thanks very much. Thanks very much, Andrea. We really did enjoy this presentation.